Hello, this is Mrs. Poland. This is Unit 3, Day 3, and we're going to examine odd and even functions, which are different than odd and even degrees, as well as graphing polynomials. So I'd like you to put the video on hold and actually try the warm-up. For the warm-up, they want you to find the y-intercept. The y-intercept occurs when x is equal to 0. So to determine it, you're going to substitute 0 in wherever you see an x. So that would be -1 times 4 times -2, which is +8. I hope you got that. For the next problem, we are actually going to graph this polynomial by hand without the use of a calculator. And the first thing you want to do is establish the degree of the function so you can determine its end behavior. So you would just try to look at that first term, which would be x squared times x, which is actually x to the 4th. So your degree is 4. Your leading coefficient is 1, which is positive. That means your end behavior is as x approaches -infinity, in other words, to the left, it's going to be +infinity, and as x approaches +infinity, your y values are approaching +infinity. The next thing we're going to do is look at our roots in multiplicity. So we have a root at -1. With a multiplicity of 2, meaning it's going to bounce or kiss the x-axis. We have a root at 3 with a multiplicity of 1, since the exponent is 1. Therefore, it's going to pass through. And let's just add another row. Sorry, it's not straight. And we have a root at 2 with a multiplicity of 1, and again it's going to pass through since the exponent is 1. To get a y-intercept, you're going to set x equal to 0. So that would be 1 times -3 times -2, or +6. And so now we're going to actually graph it. I'm going to change color pen. So we're going to graph a root at -1 and at 3 and at 2. And at 6, we know we have the y-intercept. So 1, 2, 3, 4, 5, 6. So we see that the end behavior is rise to the left and rise to the right, and we know we're going to bounce at -1, so the curve is going to look like this. It's going to pass through 2 and come again, pass through 3. And there you have the function. Notice you're bouncing at -1 and you're passing through at -2. I'm sorry, +2 and +3. Example 2. Again, we want to determine the degree first, so that's going to be x times x times x times x, or x to the 4th. Therefore, the degree is 4, and our leading coefficient is 1, which is positive. So therefore, our end behavior is it's going to rise to the left and rise to the right. Our roots are going to be x equals 0 with a multiplicity of 1. Therefore, it's going to pass through. We have a root at -4 with a multiplicity, I guess I should write this out. A root at -4 with a multiplicity of 1, and it's going to pass through that. We need to set up 2 more rows since we have 2 more roots. Again, sorry for the crooked lines. We have a root at 2 and a multiplicity of 1. And we have a root at 5 with a multiplicity of 1. To get the y-intercept, you're going to set x equals to 0. And 0 times anything is 0, so we see that that whole thing is going to be 0. And that's enough information for us to graph this. So I'm going to put this on dual screen so I can show you both at the same time with the graphing. So again, we're going to show our y-intercept of 0, which is also a root. We have a root at -4, a root at 2, and a root at 5. The end behavior is up, up, so we start going through -4, coming back through 0, passing through 2 again, and passing through 5. Again, we can't really tell how far down it's coming and how far up it's coming. We would either need to use the calculator or you would have to know calculus. But this is sufficient for this course. Example 3 is a little bit more complicated. It's not in factored form, so the very first thing is we need to factor it to find our x-intercepts. Notice that the first term and the second term, the exponents are half of one another. So that allows you to kind of just factor like normal. In other words, if this was x squared minus 10x plus 9, you would simply factor this to x minus 9, x minus 1. But since it's to the 4th, you're just going to convert that x to an x squared. We can factor this further to x minus 3, x plus 3, and the second factor to x plus 1 times x minus 1. So therefore our zeros, all with multiplicity of 1, are 3, -3, -1, and 1. To determine our y-intercept, we're going to set x equal to 0, and we get 0 to the 4th minus 10 times 0 squared plus 9, and that's equal to 9, so that's our y-intercept. The end behavior, since our degree is 4 and our leading coefficient is positive, we're rising to the right and rising to the left. And that's enough information for us to graph this. And again, I'm going to put this on dual screen so it's easier for me to see. So we're going to graph our y-intercept of 9. And then we're going to graph each one of our x-intercepts. And again, since the multiplicities are 1 for each, it's just going to pass through at each of these points. So we're going to go up. It's going to pass through at -3, pass through again at -1, pass through at 1, and pass through at 3. And let's make arrows at the end. And there you have it.